imagine giving the world's smartest supercomputer an open book test. You literally highlight the exact passages it needs to read.
Right, you hand it the answers on a silver platter.
Exactly. You give it the precise structural blueprint for how to write the essay, and you even take away the need for it to search the web.
So there's no way it can get lost looking for sources.
Yeah, the answers are entirely contained in the documents sitting right in front of it. And yet, the most advanced artificial intelligence on the planet still fails miserably. We're talking a score of like 28%.
It's wild. It completely shatters the illusion that having access to data is, the same thing as actually understanding it.
Welcome to today's custom deep dive. We know you are constantly navigating your own sea of open browser tabs today.
I mean, who isn't?
Right. You're trying to gain thorough knowledge without feeling completely buried under information overload. So today, we are looking at the invisible wall that artificial intelligence just hit.
A very hard wall, yeah.
We are exploring the transition of large language models, or LLMs, from, simple chatbots into autonomous, deep research agents.
Which are basically systems designed to write long-form, complex academic surveys completely on their own.
Or at least that is the ambitious goal the industry has set. To understand where this technology is actually at right now, we've pulled together a really fascinating stack of sources for you.
Yeah, some really cutting-edge stuff today.
We are pulling conceptual framing from the Architectures of Intelligence show, which, if you don't know, is a fantastic resource for tracking foundational state-of-the-art generative AI papers.
Highly recommend it.
And we are pairing that with a brand new, highly detailed research paper published in January 2026. It's by Kuaishu Technology and the Beijing Advanced Innovation Center. It's called DeepSynth-Eval.
And I have to say, this paper is a milestone. It directly addresses the single most critical bottleneck in modern AI development right now.
And that is our mission today. We're going to unpack why AI is absolutely incredible at finding information, but surprisingly terrible at synthesizing it into a coherent, complex report.
It's a huge gap.
And we'll explore how scientists have finally figured out a way to objectively grade this elusive, deep research capability.
Which, requires solving a massive grading problem that the industry has kind of just ignored for a long time.
Okay, let's unpack this. To really grasp why this new benchmark, DeepSynth-Eval, is so valuable, we have to look at the exact mechanism where current AI models break down.
A post-retrieval bottleneck.
Yeah. So think of current AI like an amazing, hyper-efficient grocery shopper.
Okay, I like this.
If you ask it to fetch ingredients like, go get me tomatoes, garlic, and pasta, it is flawless. It's back in a fraction of a second. That's retrieval.
Right. It grabs the exact facts you asked for.
But synthesis is asking that same grocery shopper to take those ingredients and cook a multi-course Michelin star meal.
And that's where the kitchen catches on fire.
Exactly. The AI knows how to fetch the groceries, but it has no idea how to actually cook the meal. It can't weave those disparate threads together.
If we connect this to the bigger picture, the AI industry has actually been quite good at measuring that initial fetching phase.
The grocery shopping part.
Right. We have established benchmarks for testing an AI's ability to find isolated facts. Things like GAIA or humanity's last exam.
Those are pretty standard now, yeah.
Because if you ask an AI a short-form question, it's highly binary. You can easily check if it got the answer right or wrong. The fact is either present or it isn't.
But grading a long-form synthesis essay is a completely different beast. You can't just run a quick keyword search to see if a 20-page academic survey is logically sound.
Precisely the issue. Evaluating synthesis requires verifying if the AI digested a massive amount of fragmented evidence, cross-referenced it accurately, and, organized it into a cohesive narrative.
Which is incredibly hard to grade.
Right. And until now, the industry's default method for grading this was a highly flawed concept called LLM as a judge.
Oh, man. So they would essentially take the essay generated by one AI, feed it into a second AI, and ask, hey, did your buddy do a good job writing this?
That is exactly what they did. They used a large language model to score the long-form essay, and as you can imagine, that methodology is highly subjective and incredibly unstable.
It sounds like a recipe for disaster.
It is, but most concerningly, it makes the system prone to reward hacking.
Reward hacking. Wait, so if the grading AI has a bias toward, big vocabulary words and complex sentence structures, The AI writing the essay will eventually figure that out, right?
Exactly. It catches on to what the judge likes.
So it stops trying to logically consolidate the research and just starts stuffing the paper with academic jargon to trick the judge into giving it a high score.
The model optimizes for the superficial traits the judge prefers rather than performing rigorous information consolidation.
That's basically cheating.
Yeah, it's gaming the system. Furthermore, in those older end-to-end evaluations, if the AI produced a terrible report, the developers couldn't even pinpoint the failure.
What do you mean?
Well, did the AI fail to synthesize the information, or did it just retrieve the wrong web links in the first place? You end up conflating retrieval noise with a genuine synthesis failure.
Ah, right. If you gathered the wrong ingredients, you can't blame it for cooking a bad meal. But wait, I have a question. Survey writing is inherently subjective.
Sure.
So how do you even grade it objectively? If you take two brilliant human scientists and ask them to write a comprehensive paper on, I don't know, quantum computing, they will organize it completely differently.
Absolutely, yeah.
One might structure the paper chronologically, tracking discoveries by decade. The other might structure it by methodology, grouping similar experiments together.
And they are both technically correct.
Right. You can't just tell an AI it wrote the wrong essay because it picked a different valid structure.
That is the exact hurdle the authors of the DeepSynth-Eval paper had to overcome, and their workaround is honestly brilliant.
How do they do it?
They solved the subjectivity problem by working backward from perfection. The researchers gathered 96 existing, highly cited expert survey papers, mostly from the field of computer science.
Okay, so real papers written by real human experts.
Yes. These human-authored papers became their gold standard.
So they start with a finished, perfect product. Do they just tell the AI to, mimic it?
No, they went much deeper than that. They hid the actual text of those expert papers from the AI entirely.
Oh, interesting.
Instead, they extracted the bibliography from the human's paper to create what they call an oracle context.
An oracle context.
Right. They essentially handed the AI the exact same stack of reference materials the human author used, provided a prompt based on the paper's original abstract, and basically said, here are all the sources, now you write the paper.
Oh, I see. That completely eliminates the retrieval noise. The AI can no longer use the excuse, I couldn't find the right information, because it has the exact same reading material the human expert had.
It's a completely level playing field.
That's so smart.
What's fascinating here is how the researchers then converted the highly subjective text of the human's final paper into objective math.
Because, as we said, you cannot grade style.
Exactly. So they stripped style out of the equation entirely. They analyzed the human papers and created fine-grained, verifiable checklists.
So instead of asking the judge, AI, does this sound smart? They are asking, did you hit these specific targets?
Precisely. And they divided these into two distinct categories. First, they built general checklists to test factual coverage.
Okay, so just checking the facts.
Right. This asks, did the AI actually mention the specific methods, the key design choices, and the crucial data sets that the human expert deemed essential to the topic?
Meaning, did you actually read the material and extract the salient facts rather than just, skimming the abstract?
Exactly. And the second category is the constraint checklists. This tests structural organization. Well, the researchers would explicitly tell the AI in the prompt, you must classify these algorithmic methods into these three specific categories, or you must summarize these performance data sets in a comparison table.
Oh, wow. So they're forcing it into a very specific box.
Yes. By forcing these strict constraints, they stripped away the AI's editorial freedom. The grading becomes binary again.
Right, because it's just, did the AI place the correct factual information into the required taxonomy? Yes or no?
That makes total sense. You remove the subjectivity by saying, we aren't judging your personal writing style. We are judging whether you can follow this exact structural blueprint using these exact facts.
And the scale of this benchmark is just wild. On average, for every single one of those 96 tasks, there were 199.7 checklist items to verify.
Nearly 200 distinct verifiable facts and structural requirements that the model had to hit perfectly.
That's brutal.
It is, but it completely prevents the AI from generating a generic, fluffy response and sliding by with a passing grade.
Here's where it gets really interesting, though. Now that we have this rigorous, objective grading system established, we have to talk about the sheer size of the exam these AI models were forced to take.
The scale is pretty mind-boggling.
The oracle contexts, that stack of reference papers they handed the AI to read. For a significant portion of those 96 tasks, the cumulative text length of those references exceeded 1 million words,
That is a staggering amount of data to hold in a context window.
which is essentially the AI's short-term working memory, right?
Exactly. And to put a million words in perspective, that is like being asked to read the entire Harry Potter series back to back,
All 7 books.
all 7 books, and then immediately write a comprehensive, structurally perfect academic analysis, cross-referencing specific spells and character decisions from all 7 books simultaneously.
So how does a machine even process that much text at once without its short-term memory just collapsing?
Well, the researchers tested 2 different workflows.
Right. The first one is the end-to-end single-turn workflow, which honestly sounds exactly like a college student trying to cram 1 million words of reading the night before.
Oh, totally.
And then writing the entire final paper in a single frantic, panic-fueled sitting.
That is a highly accurate analogy. In the single-turn workflow, the system takes all those references, compresses them into dense summaries to fit the context window, and concatenates them.
Concatenates them, so it's just squishing them all together.
Literally copying and pasting them into one gigantic, unbroken wall of text. It attaches stable citation IDs to each one, feeds this massive block of data to the AI along with the prompt, and demands a complete survey report in one single output generation.
No rough drafts.
No planning, no rough drafts. Just read 1 million words and write the final paper simultaneously.
And spoiler alert, cramming doesn't work for AI any better than it works for humans.
Not at all.
But before we get to their spectacular failure on the report cards, let's look at the second workflow they tested, because this one is designed to fix that exact cramming problem.
Yes, the second approach is the agentic multi-turn workflow. This is specifically designed to mimic the actual cognitive process of a human researcher.
So breaking it down into steps.
Breaking the monumental task down into 3 distinct phases. Phase 1 is global planning. Here, the AI acts as an architect.
An architect. Okay.
It doesn't attempt to write any of the final text. It surveys the task and builds an intellectual skeleton, a high-level taxonomy allocating what specific content goes into which section of the paper.
But wait, how does it decide that taxonomy if it's looking at 1 million words of conflicting studies?
Good question. It relies on the structural constraints provided in the prompt, combined with a high-level scan of the abstracts, to resolve those alignments.
Ah, so it builds a map before it starts driving.
Exactly. Then comes phase 2, the iterative writing loop. Here, the AI acts as the researcher. It goes section by section, and crucially, it performs selective deep reading.
Selective deep reading. So it's not trying to hold all 1 million words in its short-term memory at once.
Right.
It's avoiding that context overflow.
Exactly. Instead of reading everything, it looks at the specific section it needs to write, identifies only the handful of papers relevant to that subtopic, and pulls highly specific reading notes from the massive pile.
That sounds much more manageable.
It is. It writes the section based only on those focused notes, the architectural skeleton, and whatever it previously wrote in earlier sections to ensure narrative flow.
And then there's a final phase, right?
Yeah, finally, phase 3 is global polishing. The AI acts as an editor, reviewing the entire concatenated draft to smooth out the narrative and ensure global consistency.
Okay, so we have the million-word open book test, we have the single-turn cramming session, and we have the highly sophisticated multi-stage agentic workflow. The results are finally in. And honestly, they are shocking.
They really are.
In that single-turn cramming session, a smaller model like Qwen 330B basically flatlined. It scored a miserable 6.3% overall.
Meaning it failed to hit over 90% of the required checklist items.
Right. And, you could argue, well, that's a smaller model, it just doesn't have the processing power.
Sure.
But even the absolute state-of-the-art, the mighty GPT 5.2, only managed a 28.3% overall score on that single-turn test.
And giving the AI the agentic workflow, that plan, read, write, edit structure, did help. It proves that cognitive scaffolding matters just as much as raw computing power.
So the scores went up.
They did. The larger Qwen 3 235B model jumped from a 24.8% up to 35.5%, and GPT 5.2 reached 37%.
37%.
Though I should note, that's only after researchers filtered out instances where the editor agent lazily referred back to previous draft instead of actually doing the work of polishing the text.
Wait, I have to stop you there. Even at 37%, that is a massive failure.
Oh, absolutely.
We are talking about the most advanced models ever created. The AI has all the data directly provided to it in its Oracle context. The answers are literally right there.
Yeah.
Why is it still missing over 60% of the checklist items?
Yeah. It comes down to a causal mechanism the researchers call under-elaboration.
Under-elaboration.
Yes, which is directly tied to how the AI's attention mechanism works. When an AI reads a massive amount of text, its attention, which is basically the mathematical weight it uses to connect related ideas, gets diluted.
Okay, so it loses focus.
Kind of. If fact A is in paragraph 1 and fact B is in paragraph 2, it easily connects them. But if fact A is on page 5 and fact B is on page 800, the AI's attention mechanism loses the thread.
It literally loses its train of thought because the tracks are too far apart.
Precisely. So when faced with this massive cognitive load, the AI defaults to writing sparse, high-level narratives. Instead of packing the paragraphs with dense, consolidated facts and cross-referencing multiple papers, it writes vague generalizations. It skips the granular details that the human expert knew were essential.
So it's acting like a student who skimmed the reading, trying to sound confident while staying incredibly vague.
Exactly. And the mechanism completely breaks down when you apply those structural constraints we talked about earlier.
The comparison tables and taxonomies.
When you force the AI to fit this sparse, vague knowledge into a strict taxonomy or a detailed comparison table, it panics.
It panics.
Well, mathematically speaking. It realizes it dropped the attention thread somewhere in those million words. So it either completely skips the required structural elements, or, to fill out the table and satisfy the constraint, it hallucinates facts that aren't grounded in the oracle context at all.
Oh, wow.
It forces the narrative to fit the required shape rather than letting the evidence dictate the content.
That is wild. It knows that it needs a third category to complete the comparison table. It doesn't know what belongs there because it's tension diluted, so it just makes something up to check the box.
Yep.
And this isn't just an isolated problem in a controlled lab environment, is it?
Not at all. The researchers also unleashed this benchmark on external commercial systems like OpenAI Deep Research.
And how do they do?
Well, to ensure fairness, they gave the system a strict list of allowed URLs rather than a static text file. It scored around 28.7%.
28.7. Still failing.
Yes, and for a very specific reason. When bound by strict instruction-following rules, these commercial agentic systems often fail to even open or read all the required links.
Wait, really? They just ignored the links?
Yeah. The cognitive burden of following the complex structural instructions was so high that they simply skipped gathering the crucial evidence, which directly tanked their checklist scores.
So what does this all mean? If we bring this back to you, listening right now, dealing with your own stacks of reports and endless browser tabs.
It's highly relevant.
What the DeepSynth-Eval benchmark brilliantly exposes is that having access to 1 million words of data, having incredible retrieval skills, does not equal possessing knowledge.
Not even close.
Synthesis is an entirely different computational process. The AI is currently hitting the exact same cognitive bottleneck that humans do when faced with information overload.
We both get overwhelmed.
Finding the pieces of the puzzle is easy. Weaving them together into a coherent, structurally sound picture without losing the thread is profoundly difficult, even for a supercomputer.
This raises an important question that forces us to redefine what we consider intelligent behavior in machines. True intelligence isn't just recalling facts or pulling up the right source material.
Right.
It is knowing how to weigh evidence, how to discard the irrelevant, and how to organize the essential into a logical narrative. Right now, AI is a fantastic librarian for finding things, but it is not yet a master author.
The breakthrough here isn't just that the AI failed, it's how they proved it. By feeding the AI the exact bibliography a human used, they eliminated the ultimate excuse.
The retrieval excuse.
Exactly. They proved that having the data and understanding the data are two completely distinct things. But the architecture is evolving. Those agentic workflows show us the path forward.
They definitely do.
Which leaves us with a final thought to mull over today as you tackle your own reading stack. If AI development eventually shatters this synthesis bottleneck,
and it probably will, eventually.
if an agentic model can perfectly read 1 million words, hold it all in its working memory, and flawlessly construct original, structurally perfect research without hallucinating a single fact, what happens to the human role in academia and scientific discovery?
It's a huge shift.
Will humans transition from being the creators of knowledge to merely being the editors of AI-generated insights?
It would be a fundamental shift from being the chef who cooks the meal to the food critic who merely tastes it.
When the AI finally learns how to synthesize all those ingredients perfectly, Our only job might be deciding if we like the flavor. Something to think about. We'll catch you on the next deep dive.